we'll have to.
It says stream ended 10 seconds ago. Yeah.
All
Oh
right.
well.
Well, it'll start again. All right. So for folks that I accidentally hit the stop stream because I was trying to stop something
Oh,
else. And so anyway, we're picking up the stream where we left off, and so this is a whole new stream that's happening here. So anyway, hang in there. Okay, so now Chris and I were basically saying that basically it's the increment. It's trying to move, and it can't reach where it needs to go, and before it's trying to update again, and so it then just has this kind of jitter thing happening. All right, so let's go back to the code. And so we can't get rid of increment. We need increment in there, right?
no, you just the update, last update. Oh, oh,
You
okay.
need the increment in here because that's how it's chugging through. And so we then have to go back in here, and so all right. So now the question
No,
is if it is now
no, that
is it
wasn't making.
what's that?
Yeah, see, that doesn't quite make sense to me because it should have even not even fired. I don't what. Go back to the other one and see what kind of positions you're getting. Do a print. Because the milliseconds last updated interval, that's all still works. Oh, I was thinking in the no,
Just a second here.
they were moving, but they're moving very little, right? So that makes me think that the maximum and the minimum, it's a constrained range of the. I, yeah,
Okay, let's see it.
I guess it's once it's given a position, how I don't forget how the servos work. Is it
Well, that's what the increment. That's what their increment was. So let's see here. You want to see the serial monitor, and we'll go back and look at this. So it's chugging right along. I don't know how you stop that from. I don't think you can.
no? Well, you'd have to
But you
stop
can
the
see
code. I don't know how the debugger for that works.
you can see that they are randomly. They're within the random range, right?
Yeah, but I just didn't know. Sweep infers that every time it's a random. See, it's telling it to go to a new position, telling it to go to a new position, but it's not doing it every millisecond. It's doing it every interval, right? Because the first if statement blocks it if it's not its update time, and it's just milliseconds last update greater than an update interval, and the update interval is the interval that you're passing it, right?
Yeah.
Which is how fast. So just going back to your original thing, is it the 15 means how many milliseconds do I want to tell it to do a new increment?
To wait before we can move to the next position.
Yeah, but but the next position is always the current position plus a new position. And I don't know if the servo itself knows its position or if it just added, sending an add or sending a new position. So in the random, that matters because in the random function that in my brain is the servo basically just goes to a new position, period. And so the random function of a new position should be just some random value, but it doesn't know. It just the sweep function said, I need to increment into that versus just go to that position.
Well, what you're basically saying is that we need this if to say once it hits the position that we want it to be at, right? If it's not there yet, just go through and and keep moving towards it. And once it hits that one, we need to go through and make a new random one and change the increment to go the other direction and then go down that other direction. Or
Yeah,
if this is greater than this or that's greater than that, we need to do those things, right? Do you follow that?
Position.
No, probably not.
Well, I'm just trying to figure out if it's we should randomize the.
Because the reason the increment is just going up, it's incrementing one.
You're right. You're right. We need it. Yes, you're right.
And so
put the increment. Yep.
And so the increment has to be here. Now, the question here is, and this basically makes the increment opposite of whatever it is. If it was positive, it now makes it negative. If it was negative, now it makes it positive. Or actually, no, it makes the increment negative to go the other direction. Up here, it makes the makes it 1. Down here, it makes it -1 to a reverse.
Yeah, just that I think that.
So if it's out of range, it goes the other way.
It just that I think that we may need to update the position outside the. It's like when you reverse the direction is when you should randomize the position, the new position, right? Because as the position, when the sweep is seeking a position is what you want. Is it when it gets a new position, right now it says, it just reverses back down, to the minimum. But what you want to do is you want to reverse, but maybe find a new target position. Because right now I can see where, basically every millisecond position randomizes, right? And then the servo write stuff, so it writes that position. I was thinking that probably should work, except that I'm not sure, because in the if statement, that's part of the sweep.
Well, the thing is that you can like I don't like this. But what you're talking about is that there's a servo position, and then we have it do a like a delay, and like let's say it's 15,000 or whatever, and will that work?
I can't remember if the servos you give it a position and it seeks to there by itself, within a time frame, or
it does not do that. No, it basically does what whatever pulse width you give it to, it tries to start going there. But as soon as you give it a new PWM, it tries to go and start going. It tries to start going there. And that uploaded and that did not work. Oop. If you wait, maybe that's 15 seconds I actually put in there, so it's 15 seconds to move between position to position. I'm not seeing it move that way anymore.
Yeah, no, but you also once you get one, if last update, the update, you're not resetting your. Last update is millisecond, so it should be okay. If millisecond greater than update equals mils, okay, so you should get it. And then position equals random position.
So this is doing it every thousandth of a second or whatever, every tenth of a second, or every second maybe it is.
Yes. Well,
1,000, 1,000.
So it is doing it.
1,000, 1,000. But you're not controlling the speed of how fast it rotates. It's now how fast it can mechanically rotate from position A to its new position, right? So you still have to have your position A to position B, and you have to use that to calculate how much it's going to, and basically your resolution, this doesn't have any resolution, right? It's just literally A to B. It's just moving there as quick as it can. Whereas before, this is calculating that, okay, well, basically, because we basically pause the whole, this delay here pauses the whole sketch and waits for 1,000 for a second before it's going to run. And it probably also means that these two, I guess they probably are running independently, but they're both hitting a delay, and so I imagine that they can't even move at the same time because one delays would stop the other one from running. I don't know.
Yeah.
So
No, I'm sure that's true. But that's actually why the other one was just kind of going do because the servo couldn't get to the new position before probably something updated.
right.
Right.
Like if I take this now, let's save this and upload this. This should probably make it, a tenth of a second. It should update. But again, it's not like the problem is we're not in control of the speed of the servo at this point. It's just basically like, hey, I'll just like new spot, new spot, new spot.
No, I know, but that's actually what I thought because your hand wiggling stays in relatively the same spot. It just kind of jerks around in the middle of that, where you're trying to hold it. Which this sort of looks more random, what's doing now that I see it. That's actually why I was trying to get you back into the Blender mind frame, because are you trying to do a curve, or random is quantum, right? It's just like, theoretically you can walk through this wall, why don't you keep trying?
Well, and yeah, I know that for sure that you could take.
So you're
you
really
could
trying
you
to
could
you
feed
just want
this
to
through a sine.
simulate a shake.
Yeah.
Well, this looks shaky, right?
Yeah, but it's not smooth in its hold on a second
But
here.
that's what you're trying to do, is not be smooth. Because the shake, if you're smooth, it'd be either still or you're moving it, right? But you're saying you went, oh, I want to wait, I don't. Anyway, you've got the techniques kind of nailed. I think you just have to figure out how you want to, what do you call it, manage that motion. Which one is this one now? You just uploaded a new one?
This is the one we did before. And yeah, it's definitely, we could definitely do some math with it and multiply things by sine waves and stuff like that to try and get, a toe and a foot on the movement to ease in and ease out, and that would probably be a good idea. We can do that with this one, but I don't think we can do it with the other one, because it's just literally the motor's just running from position A to its new position, right? Now, let me do something really quick here. This is going back to the other style, and I just reduced the amounts, the degrees it's going to move.
Yeah. Which is getting back to where I don't know if you were actually really wanting to do a random. But it's more technique stuff.
Well, I think it's not far off. Let me do something like, hold on, just give me a second here. 65, 60. All right, so this is going back to the version 1 again with the 4 entries, 4 position minimum and maximum, and it's just reduced the amount of
The arc,
yeah,
the total min max,
of the
you
actual
basically, yeah, you've constrained the range.
right.
That and you're getting little feedback loops is probably when you increment up and down and the clocks are, it's too tight for it and it hits minus then plus then minus, within the time range.
Yeah.
And that's, from an effort, a process effort wise, I just like, being able to simulate the motion, even if it isn't, random, but you're going to be doing that in Blender anyway. So the algorithms just to take that instead of trying to something sit there independent. Well, put it this way. Why even have motions? You could just have a big fan blowing on things and it'd flutter. That's probably random.
Well, because we're gonna do why. We're basically programming something once so that we can reuse it 6 times, because I don't think we can put on 12. I sure don't know we can't put on 12 servos on one Arduino. I don't think it's strong enough to control that many. 2 is for sure fine. 4 maybe. 8 is the max it's supposed to do. So you might be able to do 6 and 6. But yeah, once you write the code, it's it's not hard to repeat it, right? You just upload it to every single Uno, and it's gonna run. And if today were the day that we're shooting, and we had to use either one of these, I wouldn't have a big deal with it.
Yeah.
We just want to make sure that they're not moving too much. It's actually, moving too much is probably worse than not moving enough.
Yeah, I did. I just how is this? Basically, you're trying to wire it up to be totally independent, so they just sit there and run.
For the long shots, yeah, for the long shots that we're shooting, because we're not paying attention to them. We're doing close-ups of the plaintiff and the defendant and the judge and all that stuff is what we're shooting. And as soon as we pop into a close-up of of one of these characters, that's digital. That's a digital process. That's not done on set for shooting. Make sense?
Yeah, and just it's more of what you want to do to control. You're basically saying this is a static thing that I set up, once and go away, which is then that's different for sure. So then it's the simpler the better for sure. But look, this is probably enough variables. I think you're fine.
I don't even think that we need to randomize the increment a whole lot. I think that, like I said, either one of those I think is fine. Like now going through and adding a laugh to it would be cool to be able to have one that when you push a button, the Arduino says, "Oh, everyone's supposed to be laughing." And
yeah, but that's a different control system because you can reload the Arduino or skip to a different. Put it this way, you could have Puppet, sweep and then laugh, or I don't know what you call this, static. Because that's you're trying to simulate static movement, right? I don't know what you want to call that. But then you have a chunk of code that based upon one of your, like you said, an input that just goes between those two algorithms, right?
Yeah,
They're,
well,
they're
it would
different
essentially
chunks
be
of code.
it would essentially be that the increment then, like if you're looking at this here, so it would essentially be like if we take the increment down to, like, let's say this down to 5 and this is down to 10. This would be the laugh. Oh, that's not working. Let me try the other one. Let's take the increment of this one down to 5 and 10.
Well, you got to watch, because if your increment, you're going past the ability for the servo to move before it updates again.
Well, that's the problem with this one. That's the problem with number 2.
Yeah.
This one
Yeah.
here has this clock in it, and so it only does 1 increment per deal. So this is changing the speed of it. This would be hard for it to not be able to keep up.
As you drop the increment, well, it's doing the right thing, right? Or doing what you expected.
Or it's uploading a little bit. I made it a little bit tighter for both of them, so they'd both be kind of. It's still not as much movement as I would expected it to, and I've dialed back the amount of movement it can do, but I would have thought that it may be, you may be right, that both of them are. And until we actually throw one of the puppets on top of it, you don't know how much each of those degrees even matters. I mean, if you're,
That's actually what I was, saying. For just the, slight motion, it might be just better to, get like a, a motor running a cam, because you kind of get the, the physics of everything.
Well, I imagine that maybe I'm actually seeing that it's not necessarily the increment that's making as big of a difference as maybe
The sweep.
the amount that they're sweeping could maybe be a bigger aspect to that. So, like, let's say, let me go do this. I'm gonna. So I pretty much added a bit more movement to this. Hold on a second, it's not uploaded yet. Okay, it's uploading now. Oh, jeez. All right. Well, we probably better wrap it up for this section.
Ultimately, I think you just, you got to get something simple and characterize it, right?
Right. And, really, it might be actually hard to even tell until we have maybe the next thing might be to actually mock up one of the characters on one of these servos to see what it actually looks like. And so we can get a better idea of how it's actually moving. Don't you think?
Well, I actually think, why don't you, I mean, you need to set the stage and start getting the stage set just to get the, because that has to do with a lot of the effects,
Right.
right?
Right.
So, and that's what I was saying. The servos, I think, use for tie-in the blender stuff in with the servos, I think is a great idea. Well, getting the randomness, the servos to do randomness, I think it's just an expense that doesn't need it. You could, like I said, put a bad, a bad vibrator on, some of these things and just have them, frequency. Well, no, if you put two different frequencies of things, you get a random motion, right?
Right.
And if you're
Right.
just looking for a little blur, or, you know what I mean.
I do.
And the other thing is that since you're doing all that, you are eventually going to do overlays of, character. I know that, you have the stick characters, but you've also got all this digital post-processing. You could, digitally post-process a little bit of blur.
Yeah, but for
anyway,
the close-ups, not for the close-ups, not for the long shots. I mean,
I know, but you don't know how that looks even now.
No, I can visualize it.
Yeah, well,
because they may not even be in focus, So it's basically you want to replicate what it looks like with normal daytime court show, where people are back there and they're moving, but they're not trying to attract attention until maybe they start laughing, and then you're gonna see a little bit more movement back there. But other than that, they're for the most part, we'll be cutting to close-ups of the judge or the plaintiff and the defendant, and they're back there and they're moving with more more vigor, and
yeah, my point is that what is it more important to shoot shoot something that these characters don't move at all, but at least you captured some of the action, or to work on creating random humanly random servo actions that may or may not work on the set anyway.
Well, I for sure, I know that us shooting the process, going in there and throwing people underneath the set and having them hold puppets, that is the easiest thing to do. For sure, that is the easiest thing to do. But that means that what we're doing right here doesn't exist. And also the people that are interested in what we're talking about here and interested in the technology of how we're getting the thing to work, you don't have any of those folks never come along because they don't even recognize that you're working on something like this. And so we can do that, but then we don't need to do any more puppet chores, right? We can just get people underneath the set to hold it. It's way easier. Right?
No, I agree with that. It just put it this way, doing because are you going with Judge Gavel? What puppets are you going with being more mannequin?
Judge Gavel is we're going to have an analog version and we're going to have a digital version. Okay, so the analog versions of all the puppets are used when the camera is kind of far away. If you're cutting into a close-up, you're going to the digital version of the puppet. That should look a lot like the analog version, right? But we're doing it digitally because it's just easier for us production-wise to get it done quickly.
Yeah. Well, my point was is that you work on that, which is probably more interesting, and what we're doing now will be a fallout of it, because it will be a simple algorithm, based on if you're going to use this thing otherwise. If this is the only thing you're using it for, then I agree with what you're doing. So.
Oh, okay.
Okay. See ya.
All right. Thank you, Chris. All right, folks. Well, that's it for this episode then of Puppet Chores, and we are getting there. We have two different methods for creating the moving puppets, and I don't know which one's working better yet. I really don't. And maybe there is still a third option. You know, I still would like to maybe do a little research and see if we can find a way to maybe get a splined version of how, you know, getting a sine wave kind of application to it, where it's maybe not such a linear movement. It's more of, you know, it has a better toe and foot and like. So anyway, I think that's maybe the next thing, is to figure out if we can do that and see if we're fully understanding how it's going from A to B and how it's memorizing that stuff. But and also I think it's also maybe a good idea to get the puppet set up to actually see what this looks like on a puppet, so that we know how much it should move and how much looks right or wrong or whatever. And if we have to do any kind of gearing, you know, I wonder about that. If we're not gonna, I don't think we'll ever use 180 degrees of movement. And so do you throw a gear or a belt drive on it so that you have more positions to drive the amount of movement that the character would need to have. So anyway, it's more things to think about later on. And if you're interested, be sure and share, like, and subscribe to Grasshorse. And if you have comments and things that you find, you have questions about, be sure and put those down below as well. So cool. All right, thank you. And until next time, keep making awesome stuff out there. Okay. Right on.